Hi, hello students. Welcome to India's most comprehensive online learning platform, BYU'S Exam Prep. Hi Sujit, good evening. This is Anil Surampudi, and in this session, I am going to give you people a complete idea on the topic addressing modes. Now, when it comes to the addressing modes, we have a lot of scope. We have a lot of scope, in especially when you talk about the addressing modes. But here, try understanding something. That is, as long as we talk about the addressing modes, most of the times we confine ourselves to discuss about, we confine in discussing about what are the various addressing modes, how the effective address will get computed. But here, I will more emphasize on, rather than effective address computation, the application of an addressing modes. Effective address, of course, it will get computed by every addressing mode. But here, I am going to give you a real-time application. That is, every addressing mode, when it is implemented within the CPU, what is the real-time application? How each and every addressing mode is going to support the programmer's life. We are going to discuss all such things. Now, in this session, we are going to talk about various addressing modes, and we are also going to talk about the types of the different addressing modes, and we are going to completely understand the total addressing modes with a simple example. I'm going to illustrate the total addressing modes by using a simple example so that thereby you'll be able to understand all the addressing modes. Okay, let us start this. Now, first of all, what is an addressing mode? Yeah. Delete and tell me once again, what is your name? I just forgot it yesterday. You just gave your name, but I missed that part. DELETA. Hi Sujit. Hi. Give me your name so that I will communicate with you directly. Yeah. What we people are doing is we people are getting into the concept addressing modes. What is an addressing mode? Addressing mode is actually required to compute the effective address every time when an instruction is being executed. We'll come to those details. Now, in this session, we will focus more on the application parts of the addressing modes rather than the implementation details of the addressing modes. What exactly is application parts of the addressing modes? Let us understand carefully. Now, when you talk about an addressing mode, hi Anu, very good evening. Now, when you talk about an addressing mode, the addressing mode is really used to compute the effective address of an instruction, effective address of an operand of an instruction. Every time when an instruction is getting executed, it may require an operand. Yesterday we discussed a simple instruction, that is addition. When you want to perform addition instruction, this addition instruction requires operand. Of course, if you want to get an operand, we are not collecting operands from the paper. When you do the computation on a paper, you will have every operand is on the paper. But here, when you talk about a computer system, in the computer system, when you execute an instruction, that instruction will have its operand in various locations, various parts of the computer system. Where the data is going to get stored? The data gets stored in the main memory. The data gets stored in the processor's register. The data also gets stored in I/O devices. Now, from where these operands are coming, in order to execute an instruction, from where exactly I need to get the operand? This addressing modes will tell us the way, will pave us a proper way. Now, instructions of a program has to operate on a data. When you have a program, Am I audible right now? Am I audible right now? Tell me if I'm audible. Anu, delete, am I audible? Hi Vishal, am I audible? Very good, fine. Now let us once again talk about addressing mode. My voice was less audible earlier. In this session, we are discussing about addressing modes. Now, we more emphasize on the application part of the addressing modes. Now, let us get into the topic of the addressing modes directly. Here, what is an addressing mode? An addressing mode is actually required to get an operand. An operand will have several locations. If you are executing an instruction, the instruction may get its operand from several locations.
What are the different parts of the computer system? What are the different locations of the computer system where an operand gets stored? The operand may be available within the main memory. The operand may be available within the processor's register. The operand sometimes may get directly collected from the IO devices. By using these addressing modes, we will be able to find out the specific location of the operand where exactly, you know, this instruction is going to fetch it. Now, let us talk about this. Of course, when you talk about instruction of a program has to operate on a data, and used to calculate, when you have an addressing mode, this addressing mode is used to calculate the effective address of an operand. By using an addressing mode, we will be able to compute the effective address of an operand. Sir, what is effective address? Let me tell you. For this, let me take the help of yesterday's session. In the previous session, we used one example. Let us say, excuse me. Let us say there is a main memory. In main memory, in 25th location, there is a value 500. In a instruction, we do have some instructions like add 25, and the add is preceding with a 0. Let us say this add is in a direct addressing mode. If the add, this instruction is said to be in the direct addressing mode, that too in this instruction, if this operand is said to be in a specific direct addressing mode, what do you mean by that? This direct addressing mode specifies an address in which the operand is present. Yesterday we discussed that, right? In the direct addressing mode, the address will be specified, the operand will be specified in terms of a direct address. So here, taking this address, when we go to the main memory, we will collect the operand. This is the direct addressing mode. Here, what is an effective address? The effective address is a location where the operand is available. Effective address is the exact location where the operand is available. Okay. Now let us say in the case of an indirect addressing mode, let us say this 25 is said to be an indirect address. If it is an indirect address, what exactly is going to happen? Excuse me. If it is an indirect address, this 25, when you go to the 25, you will find one more address. You don't find an operand. At that time, you need to collect this 500 as one more address. You need to access one more main memory location in which the actual operand is present. Right? So here, the part that you need to understand is effective address is an address in which the operand is available. In the previous case, 25 is the effective address. In the indirect case, 500 is the effective address. Now you can understand that the effective address is an address in which the operand, the actual operand is present. Are going to be loaded in, yes, address registry is going to be loaded for 2 times. Absolutely, you're spot on. Now, let us talk about different addressing mode initially. Now, before I get into the details of any addressing mode, let me admit some important thing here. You buy any processor. You may buy, 8085, you may buy 8086, or you may buy any of, any processor, i3, i5, i7. When you look at the addressing modes, you may find the addressing modes are different from processor to processor. If 8086 have a set of addressing modes, i3 will have a different set of addressing modes. i5 will have a different set of addressing modes. Snapdragon will have a different set of addressing modes. So what exactly is this difference? Why we need to have different addressing mode? Understand something. Addressing modes are not different. There are some standardized addressing modes on which all the other customized addressing modes are built. For an instance, now here we are going to discuss all those standardized addressing modes from where any of the processor are going to get and modify those addressing modes and customize them to implement in their respective processors in their respective way, depending on their application, depending on their requirement. I hope you got the point. Any processor can have any number of addressing modes. But only the thing is, when we discuss the standardized addressing modes, we will be able to understand any addressing mode of any processor, because all the addressing modes that every processor uses based on the addressing modes that we are going to discuss right now. Okay, now let us get into the actual addressing modes. Now, Instructions for a program has to operate on a data, as I already told you, and used to calculate the effective address. It is an address in which the actual operand is available. Now, the number of addressing modes vary from the processor to processor, as I already told you, and let us start with the addressing modes. When you talk about a complex CPUs, just one more thing to add. When you do have some complex CPU, what is a complex CPU? The complex CPU is built on some complex mechanism. That is, let us say now i3. When you compare 8085 and i3 is considered to be very complex because the instruction set that is being followed by i3 is very complex. That is, the number of instruction, the number of machine language instruction that are being followed by the i3 are very complex, vast in number. When there are more number of instructions, it has to be supported by more number of addressing modes. So the complex processors will have more complex addressing modes. But all those addressing modes are based on the standardized addressing mode that we are going to discuss about. Every addressing mode enables a specific feature of a program. Now, first of all, why we need to have all these addressing modes? We are talking about right from yesterday, we are talking about the design of the CPU. When you design the CPU, what are the basic entities that are needed to design? The entities that are needed to design is, CPU itself, in the CPU, register set, control unit, and the ALU. After which we started designing machine language instructions. Then we are talking about, the addressing modes. Why all these things? Why do I need all these things? These things are actually required for program execution. Yesterday we discussed something. What exactly? I will tell you. I will come to that point. Just hold on. Yesterday I already gave you one detail regarding the addressing modes. Direct addressing mode, in the indirect addressing mode, we have seen how the operand is being fetched. Sure. Hold on for a while. You're going to understand everything. Okay. Every addressing mode enables a specific feature of a programming language. Now the thing is, why we are designing, why we need to have instructions, why we need to have an ALU, why we need to have an addressing mode. All these are helping the programming paradigm. Because the computer system fundamental is a program execution machine. All these are going to make this program execution paradigm more sophisticated. Let us say, in my programming, I need to use a specific features. For an example, in a programming, I need to run loops. In the programming, I need to run relocation. In the programming, I need to run branching. In order to enable all these things in a programming, in order to enable all these features in a programming, I do require addressing modes. How, what, why? Let us have a look at. Let us, for a small example, you talk about a pointer, right? You talk about a pointer. Without pointer, there is no programming language. All the programming language must support pointers. Let me admit one more thing. Without pointer, there is no computer system even. If you want to load a program, even if you want to load a program in main memory, I do need to make use of a pointer, right? I will tell you about why, we require a pointer to load a program into the main memory later, but understand that pointer concept is a important concept that has to be adopted by every CPU and every operating system, without which no programming, language is going to execute its program. Now, if you want to have your pointers implemented in a program, first of all, this must be supported by indirect addressing mode. Yesterday, we have discussed about an indirect addressing mode, right? In the indirect addressing mode, the operand is available. The operand is available not in the direct address, rather in the indirect address. The instruction is giving you one address in which there is one more address. In that one more address, we got the actual operand. This is an indirect addressing mode. If there is no indirect addressing mode, there is no pointer at all. Pointer is needed because pointers directs to address. I will talk about this. Why pointer, how the pointers are actually needed. Okay, let us hold on. Now, what are the different addressing modes? Stay focused and understand. In the next 40 or 45 minutes, what you're going to witness is very important to the fundamental understanding of your programming languages, to the fundamental understanding of COA. Yesterday, we had done, the enough work to understand, to get a better idea on a COA. We discussed about a register set. We discussed about the instruction cycle. Now if you actually can understand these addressing modes, we are going to have one more step ahead. Now let us talk about these addressing modes. Altogether, I am going to talk about 11 to 12 addressing modes. And when you understand them, we are done. CPU design is almost done. Okay, let us start with. The first addressing mode that we are going to talk about is the direct addressing mode, followed by indirect addressing mode, which we have already discussed, but one more time I am going to explain them, right after which I am going to talk about the implied addressing mode, then immediate mode, register indirect mode, auto increment addressing mode, auto decrement addressing mode, base register addressing mode, and index register addressing mode. In addition to which, we also are going to discuss something called a relative addressing mode. Okay, ready? Any doubts so far? Beg your pardon, in the earlier my voice was not audible, the mic was not set properly. So now, if everything is audible, visible, I'm going to take you people into the world of addressing modes. Are we ready? Anu, and you gave your name. Vishal, and one more guy. Are we ready? Yes, very, very good. You there, Anu and Vishal? Very good. Now, let us talk about the direct addressing mode. Once again, of course, even though we discussed about the direct addressing mode yesterday, let me give you one more idea, for the idea on the direct addressing mode for one more time. Let us have an instruction. Here, I am, discussing this addressing modes from the perspective of a simple computer system in which we used single accumulator organization. What is single accumulator organization? I explained yesterday. In the single accumulator organization, we do have next to the opcode, we do have only one operand specified within an instruction. Second operand will always be accumulator. We already discussed about this. So based on this, I am going to demonstrate all the addressing modes right now. Now, let us say direct addressing mode. In the direct addressing mode, the opcode will be followed by the address part of an instruction. This address part of an instruction is going to specify an address of the operand. That is, when we go to the specific address in the main memory, we are going to get the operand. Finally, what is the second operand in our instruction? Second operand is always accumulator in our computer system. So finally, the accumulator is equal to accumulator plus memory of 450. What is memory of 450? 1000, right? So the accumulator will be accumulator plus 1000. This is direct addressing mode. Okay, and the next thing is indirect addressing mode. We don't need to talk about the indirect addressing mode much, because here in the address part of the instruction, we do have an address in which there is one more address when you go to the main memory. There is one more address when you go to the main memory. When you go to the main memory and access it, you are going to find out one more address. Okay, so now accumulator will be equal to accumulator plus memory of 450. That means this is no more an address, rather it is no more an operand, rather it is one more address, taking which you need to access the main memory for one more time, in which whatever the operand is present, that will be considered as an operand, and finally that will get added to accumulator. This is what the indirect addressing mode is all about. In the indirect addressing mode, the address part of the instruction contains an address in which there is one more address in the main memory. Okay, now these are simple. We don't need to talk much about the direct addressing mode and indirect addressing mode. Let me take you people to the next addressing mode. The next thing is, I discussed about already. The next thing is implied addressing mode. What is implied addressing mode? Understand something. In a computer system, in any computer system, some of the instructions doesn't have their operands explicitly specified. For an instance, there are a few instructions. Some instructions are like this. CLA. What is CLA? CLA stands for clear the accumulator. Clear accumulator. During the execution of CLA, the contents of the accumulator will get cleared. Very good. Accumulator is equal to accumulator plus memory of 450. What is needed? What is the need of indirect addressing mode? When we have direct addressing mode? I will talk about the application part in some time, so hold yourself for a while. Initially, the flow will be like this. We will understand every addressing mode, the way it calculates sir, CMA, I didn't get you. Okay, CMA. CLA, CMA, I'll come to that, but let me answer this. Let me explain each and every addressing mode in terms of calculation of the effective address. Right after which, I will explain you how and what and why these addressing modes are used, these addressing modes are implemented, and in what way these addressing modes are exploited by your programming languages. I will come to that part, but hold on for a while. Now, there are a few instructions such as CLA. When there is some instruction called CLA, it means it's clear accumulator. But here, let us understand something. CLA is an instruction itself. CLA is not followed by any of the operand. I did not say CLA 450, CLA 550, CLA 500. No, right? There are a few instructions for which we don't require any operand to be specified explicitly. I hope you got my point. Those instructions, they themselves contains the operand within them. For an instance, I will give you one instruction which is pretty much familiar to you. There is an instruction push. Do I need to say anything addition to this? Should I need to say push A, push B? No. Push itself, it's an instruction which doesn't require any operand. Push meaning the contents of the data register will be pushed into the stack. I hope you got my point. That is, there are a few instructions in every processor. Those instructions doesn't require an operand to be specified explicitly. For instance, CLA stands for accumulator will get cleared. CMA stands for the contents of the accumulator will get complemented. You know exactly what is complementing. 0 will get converted to 1, 1 will get converted to 0. This is exactly what an implied addressing mode. In the implied addressing mode, the instructions will not be specified with an explicit operand. The operands are contained within the instruction itself. CLA, CMA, INC. There is an instruction INC. What is? Incrementing. What to be incremented? Of course, accumulator will get incremented. Okay. The operand is implicitly specified in the instruction. Anu, you are spot on. Santoshi, yeah. Very good evening. And you are late by 5 minutes. But fine. Just you can focus and you can stay in the class so that you will be able to understand better. Just now I started all the addressing modes. Now in the implied addressing mode, what exactly is going to happen? The operand is implicit within the instruction. That is CLA. CLA meaning clear the accumulator. The total meaning of the instruction in addition to the operand, everything within the instruction itself. Okay, that is what the meaning of the implied addressing mode. The next thing is, of course, I told you that CLA, CLA and INC. Next thing is immediate addressing mode. What is an immediate addressing mode? INC, very good. I appreciate. But INC stands for incrementing, as we are talking about COA. Okay, we are not in politics. If it is politics, I mean, INC mnemonic has a different meaning, but as long as COA is concerned, I would say that INC is always incrementing. I don't know about, Indian National Congress or anything else. Okay, immediate mode. What exactly is this immediate mode? Let us talk about. Let me give the same old example. Add 450. This is the instruction. Now, in the direct addressing mode, 450 is a direct address. In the indirect addressing mode, 450 has one more address within the main memory. But when it is said to be in the immediate addressing mode, this 450 is the direct operand. The 450 itself is the operand. I hope you got the point. That is, accumulator is equal to accumulator plus 450. The direct value of the operand will be specified within the instruction. We don't need to neither go to the main memory, nor go to the processors register, nor go to the IO devices to fetch the operand. Operand is directly specified within the instruction in the address part of the instruction itself. I hope you got me. Sir, change pen color to make it more clear. Sure. Yep. Of course, it's a break time, but yeah. Sorry for this technical delay, but fine. I am able to change the color, and computer system has been resurrected back to the working. Now, we've been discussing about immediate mode. In the immediate addressing mode, the address part of the instruction is going to specify the operand directly. The address part of the instruction is going to specify the operand directly. We don't need to go anywhere to collect the operand. The address part of the instruction itself, within the instruction itself, I would say the operand is present. Yeah, sometimes require more bits than an address. What is this? We are going to discuss later. Now, what is the register addressing mode? Gaurav Kumar, hi, hello. Gaurav Kumar, yeah, what do you mean by register addressing mode? In the register addressing mode, understand something. A processor's register will be specified within the instruction which holds the operand. Here, in the, let us say, I do have an instruction add. Earlier, the add was being supported by an address part of the main memory in which the actual operand is present. But if the operand is said to be in the register addressing mode, the instruction will be supported by a processor's register. Let us say add R1. What exactly R1 means? R1 means a processor's register. Within a processor, we had several processors register, R1, R2, R3, R4. Here, R1 is one of those registers where it contains the operand, which means that accumulator is equal to accumulator plus R1, the contents of R1. The contents of R1 will get added to accumulator. I hope you got my point. Yeah, example add R1 meaning accumulator is equal to accumulator plus R1. Next thing is a very important addressing mode. A very important addressing mode. Raj, thank you. And of course, you are going to understand it more clearly right after you finish understanding each and every addressing mode that has been explained in this session at the end of the session. Okay, now I'm going to explain one of the important addressing mode. Now, this is a register indirect addressing mode. What is register indirect addressing mode? Of course, in the register indirect addressing mode also, within the instruction, a processor's register will be specified. But here only the difference between register direct and the register indirect is, in the register indirect, the register that's been specified within an instruction has a memory address. Now, it doesn't have an operand directly. Now, again you go to R1. R1 of course is the processor's register. In the R1, I do have one value which is called 450. In the register direct, the contents of R1 will be added to accumulator. But in now, the contents of R1 is going to only show a memory operand. So now, by taking this, we need to go to the main memory under which whatever the value should be collected and should be added to the accumulator. That means that accumulator is equal to accumulator plus memory of R1. Effective address is memory of R. Perfect. Anu. Register specified in the instruction contains a memory address. Contains a memory address. That means accumulator is equal to accumulator plus memory of R1. This is how register indirect functions. Hold on. This register addressing mode and register indirect addressing mode are going to open a wide variety of doors to many features of your programming language. What are those features? You need to hold on. I'm going to reveal them at the end of the class. Now, the next thing is auto increment or auto decrement addressing mode. Stay focused and understand. Register has memory address in indirect. Register indirect, yes. Raj, registers has memory address in the register indirect. Okay. Now, auto increment or auto decrement addressing mode. What exactly is this? Auto increment addressing mode or auto decrement addressing mode is pretty much similar to register indirect addressing mode. How? Recall register indirect addressing mode. In the register indirect addressing mode, the instruction is specified with a processor's register, contained a processor's register. The processor's register has a memory address. We went to the memory address. We collected the operand. We performed the operation. In the register indirect, right? Here, till here, auto increment addressing mode is pretty much similar. Okay? With one difference. I'm not talking about auto decrement. I need to confine this to just auto increment. Auto increment is exactly equal to register indirect, I would say, with one small difference. What is that small difference? Understand carefully. The register which is specified within the instruction contains a memory address, of course. We go there, collect the operand, get the operation performed, right after which in the auto increment addressing mode, finally we need to go back to the register again to increment the content for one time. How exactly it works? Let us understand. There is a processor's register R1, right? Let us say the contents of the R1 is equal to 450. Now, the instruction is add R1, which is said to be in auto increment addressing mode. In the auto increment addressing mode, what did I tell you? The operation will be pretty similar to register indirect. That is, we need to go to R1, take this memory address, go to that memory address, get the content. The content is 1000, let us say, at this point of period. Then accumulator is equal to accumulator plus memory of R1, which is 1000, right? Accumulator is equal to accumulator plus 1000, I would say. Finally, the operation has been performed, the instruction is executed. Here, there is one more small step that is needed to be performed in auto increment addressing mode. That is, right after you perform the operation, you need to go back to this register to increment the contents. That is, in the auto increment addressing mode, after performing all the operations, finally, we need to go back to the register and increment the contents. This is what the slightest difference in between register indirect and auto increment addressing mode. Okay. Now the thing is, we need to talk about auto decrement addressing mode. I do have a question. Now, can you tell me what is auto decrement addressing mode? So far, do you have any doubts? You can ask me right now. I want you people to throw the doubts if you do have. Shoot it right now. Any doubts? Any doubts, Raj? Any doubts, Anu? And any doubts, Gaurav? Vishal? After effective increment contents of the register. Yes, Anu, you're right. Very good. Thank you. Now, what is auto decrement addressing mode? How auto decrement addressing mode actually works? How auto decrement addressing mode actually works? Anu or Raj or Gaurav or Vishal? There's a question from my side. Wonderful. Very good. In auto decrement, of course, what exactly is going to happen is, of course, auto decrement is quite similar to auto decrement addressing mode. Sorry, auto decrement is quite similar to auto increment addressing mode with one difference. That is, in the auto increment addressing mode, right after we perform the operation, we will go back to the register to increment the contents. We need to go back to the register to increment the contents, right? Once again, the instruction is add 450. Okay, sorry. Add R1. R1 is equal to 450. Now, going to 450, collecting the operand, performing the operation. Operation has been performed and finished. Right after which, we are going to R1 to increment it. This is auto increment addressing mode. Now, when it comes to auto decrement addressing mode, what exactly is going to happen is, not after the operation, prior to performing the operation itself, we will go to the register that is specified within the instruction. We go to the register that is specified in the instruction. We are going to decrement it, and after which the operation is going to happen. Now, understand this. Let us say add R1. Now R1 is said to be auto decrement addressing mode. Now exactly how the effective address is going to be calculated. We need to go to R1. The content of the R1 is 450. If it is auto increment, we are going to take this, we will go to the main memory. But in the auto decrement addressing mode, first we will decrement the contents of the register. the contents of the register will get decremented. That is 450 minus 1 will be equal to 449. Okay. After which we will take this address and we will go to main memory. In the main memory, let us say there is 500. This content will be taken and will be added to accumulator. Accumulator is equal to accumulator plus memory of R1 minus 1. Okay. I hope you understood the difference. Sir, why to decrease before the execution and increase after the execution? Again, I told you, yes. Again, I told you something that, in the beginning of the session. Initially, we will understand everything. Just you hold your horses for a while. Initially, we will understand the, meaning of each and every addressing mode. I will come to your, the doubts. I will come to what is happening in your mind. Why exactly we need to have all these addressing modes? Let it put it this way. Here it could be Anu, it could be Raj, or it could be, Vishal, or it could be somebody else. Let me put it this way. See, first of all, my question is, not only you, while I was going through the addressing modes for the first time in my life, the first question that I asked my lecturer, maybe, I did not ask, but the first question that has, arisen in my mind is, why I need to have all these addressing modes? Simply, why can't I use, immediate addressing mode? In the immediate addressing mode, the operand will be simply available within the instruction itself. Why are we using a hell lot of addressing modes? Why we need to use all these addressing modes? What is the point? What is the reason? I will come to address them. You don't, worry. Now, at this point, when it comes to the auto decrement, the register which is specified in the instruction will get decremented first, after which we are going to collect the address. Going there, we will collect the value which is under the specific memory location. That value will be added to the accumulator. This is auto decrement addressing mode. Now, let us go to the next addressing mode. Here, when the address of the register is used to access the memory, then the value in the register is incremented or decremented by 1 automatically. But only with one difference: in the auto increment addressing mode, right after performing the operation, but in the auto decrement addressing mode, before performing the operation itself, the contents of the register will get incremented. The next, the addressing mode is a relative addressing mode. What exactly is the relative addressing mode? Let me explain you by taking a simple example here. Now understand. Don't read anything. By using a simple example, I'm going to make this relative addressing mode very, very clear. Okay. Now let us say the current instruction that is being executed by the CPU is 23. Okay. Now the thing is, in 23, there is one instruction such as call 21. Okay. Call 21. Now, if it is in the relative addressing mode, how the effective address is going to be calculated? Here in the relative addressing mode, the effective address will be calculated as the address part of the instruction, that is, the value that is specified in the instruction will be added to the program counter value. The program counter value will be added to the value that is specified within the instruction in order to calculate the effective address of the operand. Here the effective address of the operand is program counter value plus, that is, the value that is specified at the address field of the instruction. Both together, when they get added, we are going to get the effective address. That is 24 plus 21, that is 45. The effective address is 45. Here, a branch has to be made to 45. The effective address is 45. How the effective address is calculated? The address part of the instruction must be added to the program counter value in order to calculate, in order to get to the target address. Okay. Program plus address part of the instruction. Program counter plus the address part of the instruction. Okay. This is what the relative addressing mode is. Okay. Again, one more question. Why we need to have a relative addressing mode? Hold on. This is also one of the important addressing mode which has to be understood precisely. For that, at the end of the class, I'm going to tell you the application where you're going to drop your jaw, I may reckon. In the relative addressing mode, the address field of an instruction, is going to specify the part of the address, abbreviated address, which can be used along with the program counter to calculate the effective address of the operand. That is, effective address is equal to address part of the operand plus the address part of the operand, address part of the instruction plus the program counter value. This is how in the relative addressing mode we are going to compute the effective address. The address field of the instruction is short. Large physical memory can be accessed with a small number of address bits. What exactly is this? I am going to explain you at the end of the session. What is the actual importance of the relative addressing mode? The next thing is base register addressing mode. How exactly base register addressing mode is going to work? Let us understand this. Okay. Every computer system, in addition to the regular registers, they are also provided with two more registers. One is called base register and one more is called index register. Okay. Some computer system directly name the registers after base register and index register, but some computer system doesn't provide the base register or index register. Some of the general purpose registers will be used as a base register and an index register. I am not getting into those system specific details, but understand at this point our computer system is provided with two registers. One is base register and one more is index register. And now we do have an instruction that is add 450. Now, of course, you know that this is the address part of the instruction. Here, in the base register or an index register addressing mode, how the address is going to be computed, how the effective address is going to be computed. The effective address will be calculated as address part of the instruction plus contents of the base register if it is in the base register addressing mode. In the base register addressing mode, the contents of the base register addressing mode will be added to the address part of the instruction in order to calculate the effective address. That is, let us say the contents of the base register is equal to 100. 100 plus 450 is equal to 550. Effective address is equal to 550. So going to 550, we will be able to, get the actual value, whatever it is present in that specific memory location, that must be added to the accumulator. Accumulator is equal to accumulator plus memory of 550. How we have arrived to 550? We have added the address part of the instruction to contents of the base register in order to get the effective address. I hope I made it myself clear. Okay. So this is the base register addressing mode. The index register addressing mode will also be the same, but only the thing is address part of the instruction will be added to the contents of the index register rather than base register. Here in the base register addressing mode, address part of the instruction plus base register contents will be the effective address. But in the index register addressing mode, address part of the instruction plus contents of the index register. Contents of the index register is equal to, let us say, 200. 200 plus 450. 200 plus 450 is equal to 650 is the effective address. You need to go to 650th memory location to get the operand for the instruction. Accumulator is equal to accumulator plus memory of 650 in the index register addressing modes. Are we clear? Shall we go further? Shall we go further? What is the base index register? How they come in picture? Yeah. Okay, let me address this at this point of a period. Stay focused, all of you. Yesterday we discussed about a register set, right? Every computer system should have a register set. In this register set, some registers are, let us say, special purpose registers. Okay. And some registers are general purpose registers. Either it could be a special purpose register or it is a general purpose register. Fundamentally, the computer register is going to store the data. If it is a special purpose register, the special purpose register is used to store a specific kind of a data. I will tell you what is a base register. Every computer system needed to provide one register called a base register. the base register is actually required for the operating system. Let us say I'm an operating system. I just want to give the address space to each and every program. When a program comes into the main memory, the program needs to occupy a stipulated main memory location. Let us say the program P1 is of 100 instruction. My main memory has 1000 locations, 0 to 1000. Okay, where this program has to get loaded, how I can track how exactly this program is getting loaded, what is the origin and what is the the final address of the program. I need to keep track of this. I need to maintain the file of this program, right? In order to keep the track of this, I require one register called base register, one more register called limit register. Now, every time when a program is being loaded into the main memory, the starting address, let us say this program, which is of 100 instruction, has been loaded from 250th location to 349th location. So the address space within the main memory that is allotted to P1 is 250 to 349. Okay, the moment the program arrives into the main memory, operating system transfers this starting address into the base register. Okay, the starting address of P1 is equal to 100. Okay, every time when the P1 is executing, operating system will look at base register. That will, this is not 100, right? Bigger pardon. The starting address is, 250. Bigger pardon, it is 250. So the starting address is in this case 250. Operating system will see the base register. And operating system will also see the limit register. What is the limit register? Limit register holds the final address, 349. So operating system checks. This program is executing. All the time it will check if the program is executing only in between 250 to 349. If the program try to access any other location, immediately operating system will kick this program out. We are allowed to reside only at our home. We are not allowed to reside at some other home, neighbor's home, right? If you go to neighbor's home and if we sit relaxedly, they will kick out. Similarly, when a program comes into the main memory and occupies some space, this program is allowed to access only that memory space, right, from 250 to 349 as long as it executes. But sometimes what if you try to access some other memory space? Immediately the operating system will not allow. So in order to keep the track of every address space of every program, it will use two registers. One is base register and one more is limit register. Okay, but I will give more emphasis on this base register and limit register. Hold on for a while. So similarly, we do have one more register called index register. That index register also will be associated with every processor, but sometimes the name may be different. Every processor will also be associated with having one more register called index register. So exactly, what is this? What is this? Let me say this. There is, yes. Now, effective address is equal to contents of the base register plus address part of the instruction in case if it is the base register addressing mode, effective address will be calculated as the contents of the base register plus address part of the instruction. Next thing is index register addressing mode. Effective address is the address part of the instruction plus address, the contents of the index register plus address field of the instruction. Now, let us have a look at. With this simple example on the board, I'm going to summarize the entire, the addressing modes concept. But after that, I'm going to give you an emphasis. I'm going to, elaborate on what are the specific purpose of each and every addressing mode. For that, stay tuned. Now, here, understand this. This part is specifying some of the registers of the processor. This part is specifying some of the registers of a processor, where we do have a program counter, where we do have some R1 register, where we do have something called an index register, and where we do have an accumulator. Now this is the program. Rather, this is the main memory. This part of the main memory, this part is actually, showing the main memory. The main memory holds a program now that is being executed by the processor. In the processor, the current program that is being executed, and that too, the current instruction that is being executed is 200. Okay. Processor is currently executing this 200 instruction. If the 200 instruction is being executed, the program counter for our system is going to show 201. The program counter value is equal to 201. Okay. Now, let us understand. An instruction is needed to be executed. The current instruction that is being executed is add 500. If it is add 500, how this instruction is going to get executed in different addressing modes. For an example, in the direct addressing mode, what is going to happen? Yes, in the direct addressing mode, effective address is 500. That is, we need to go to the main memory location 500. Thereby, we'll be able to get the data. Finally, the contents will be added to the accumulator. Accumulator plus memory of 500. Okay. In the indirect addressing mode, what is going to happen? This 500 is no more an address. Sorry, this is no more an operand. One more time. This 500 is no more a direct address. Rather, it is an indirect address. So, going to that 500 location, you're going to find out one more address. Now here, 800 is the effective address. So the effective address in the indirect addressing mode is equal to 800. So whatever is in the content 800 will be added to accumulator. Accumulator is equal to, where is this? In the indirect addressing mode, accumulator is equal to accumulator plus memory of 500. That is, memory of 500 is equal to 800, memory of 800 is equal to 300. Memory of 500 is equal to 300. So the accumulator is equal to accumulator plus 300. So that is in the indirect addressing mode. In the immediate addressing mode, we don't have any effective address. Rather, the contents will be taken as a direct operand. The direct operand, that is 500, will be added to the accumulator. Finally, the accumulator is going to get updated. Next thing is the relative addressing mode. In the relative addressing mode, what is going to happen? The program counter value will be added to the address part of the instruction. What is the program counter value? 201. Address part of the instruction is equal to 500. When you add both, you will get the effective address, that is 701. The contents of the 701 will become the operand. The accumulator is going to be added with the contents of the memory location 701, that is 325. Here, the effective address for the relative addressing mode is equal to 701. Okay. Then, what is indexed addressing mode? In the indexed addressing mode, the address part of the instruction will be added to the index register. What is index register? Index register is 100. So, effective address will be equal to 500 plus 100, that is 600. Okay. In the indexed addressing mode, 600 will be the effective address. Okay. In the register addressing mode, we don't have 500. Rather, register addressing mode will be simply like this. Add R1. Alright. So the contents of the R1, what is R1? R1 is equal to 399, will get added to accumulator. And now when it comes to the register indirect, in the register indirect, the contents of the R1 are not the direct operand. The contents of the operand is going to specify a memory address. So now, going to that memory address 399, we are going to collect the operand. In the register indirect, the effective address is 399. The contents under the address 399 will be added to the accumulator. Next thing is auto increment. In the auto increment also the effective address will be the same, because auto increment is pretty similar to the register indirect till at some point, right? Only after that point the contents of the register will get incremented. But auto increment and the register indirect are one and the same at most of the times. Finally, in the auto increment, what is going to happen? Finally, after performing the operation, R1 will get incremented. I hope you got the point. But when it comes to the auto decrement, what exactly is going to happen? Auto decrement is not similar to auto increment. Initially, we need to go to the register which is specified within the instruction, decrement it, and take the effective address. So the effective address in the auto decrement is 398, because in the auto decrement addressing mode, we need to decrement the register that is provided within the instruction. The register that is provided within the instruction is R1. R1 is equal to R1 minus 1, which is equal to 3 398. Okay, so the effective address is equal to 398. Okay, now stay focused. As we discussed all the things, now let us understand about the applications. Which addressing mode is for which purpose? Understand carefully. Are you ready? You're there? Anu, Raj, and Vishal. You guys are here. Shall we get into the important part? This is more important. Understanding this addressing mode is very simple. How the effective address is going to be computed so far, will be a cakewalk. Within no time we'll be able to understand. Shall we? Very good. You there, Anu? You there, Raj? Yes. Stay focused right now. The application part. Now let us say you have many questions. Why I need to have these addressing modes? If I do have a direct addressing mode, can't I, have it done? Can't I be satisfied? Wouldn't that be sufficient to implement in the computer system? There are a lot of questions. Understand something. That is, when you execute a program, you may require a lot of things. For an instance, you want to declare a variable. You cannot declare a variable, sir, if you do not have a direct addressing mode. If there is no direct addressing mode supported by the processor, there is no variable declaration. You can't declare a variable, simple. How the variable is being declared? Understand? Let me erase all these things. How a variable is being declared? For that, you remember? If you say int a, what your books are stating, whenever we say int a memory location will get created, right? This a is nothing but a memory address right now. So immediately the moment you declared int a memory location will be created and allocated to this variable a. Every time when you access this a, when you try to update this a, when you try to refer that a in your programming language, in your program execution, this a is going to access that specific memory location, which is the direct addressing mode, which is exactly what we people are doing. Now, in your program, you said that a plus plus. Rather than, you used a plus b. This is what you want to perform. Now, when you express this instruction in your programming language, rather in your program, what exactly is going to happen? The computer system identifies this a by its address. A is given 450. Immediately it goes to 450 and it collects the value. Okay, and immediately it goes to B, whatever the address that is allotted, let us say it is 550, it collects the value. So, in order to declare a variable, I do require a direct addressing mode. I hope you got the point. There is no direct addressing mode, there is no variable declaration. Now let us talk about indirect addressing mode. Indirect addressing mode, as I already told you, indirect addressing mode itself will tell you it's a pointer. Okay. Indirect addressing mode, yes, to implement variable, that is what I said, right? Yeah. Indirect addressing mode is to exploit the concept of pointers. Let me tell you something, there is no pointer, there is no computing environment. I'll come to this pointer at the end. Now, see, one more thing is, if you do not have a pointer, none of the next subsequent addressing modes can be implemented within a system. Any of the addressing modes, let us say indirect, relative, index, register, indirect, everything are based on the indirect addressing mode. If there is no indirect addressing mode, forget about everything. You pack the bag and you can leave the computer architecture. Indirect addressing mode is going to be, base of all the other addressing modes, right? Just a minute. All the other addressing modes, because indirect addressing mode is the base. All the other addressing modes are based on indirect addressing mode. Okay. Now, next thing is an immediate addressing mode. Next thing is an immediate addressing mode. Could you please tell me what feature of the programming language is being supported by the immediate addressing mode, will get enabled by the immediate addressing mode? Anu? For implementing constants, if you cannot have the immediate addressing mode, you can't implement constants. What is constant? Yep, constant is going to be declared the way pretty similar to the direct addressing mode. Rather, the constant is going to be declared the way pretty similar to a variable. You can say either it's a variable or a constant, a memory location will get created. But if it is declared as a constant, every time when you want to access this, it will not be accessed by the address. Rather, it will be accessed directly by the value. The value of this memory address will get transferred to the processor's register, and this value and this memory location will never get affected. Because the constant, once after it gets declared, it will not get updated, right? This is the very reason why the constants are a must in the computer system, rather must in any programming language, and that is going to be supported by a concept of the, what is the addressing mode? Tell me, what is addressing mode? Which addressing mode is going to enable the constants? Yes, the constants will be supported by immediate addressing mode. Yeah. Next thing is implied addressing mode. What is implied addressing mode and what is the usage of the implied addressing mode? Implied addressing mode, I discussed about, when you talk about the implied addressing mode, this implied addressing mode doesn't have any explicit operand, right? Let us say add, let us say 450. It is said to be in the direct addressing mode. But for a few instructions, such as CLA or CLE or INC, what exactly is going to happen? This did not specify any implied. I did discuss implied addressing mode. I did discuss. Did you forget? In the implied addressing mode, we do not have the operand explicitly specified. In this, I did not include implied addressing mode because there is no address here. Okay. Here, I included only those addressing modes in which we do require an operand explicitly. But in the implied addressing mode, I don't require any operand explicitly. For CLA or INC, we don't require any operand explicitly. Most of the times we use the implied addressing mode to update the accumulator. You know that every time an instruction gets executed, accumulator needed to be updated. This instruction execution, the output of the instruction execution should get transferred to the accumulator. In the single accumulator organization, accumulator will be updated by every instruction. But in general register organization, we need to make sure that accumulator will be updated parallelly with each and every instruction. So most of the processor will implement this implied addressing mode instruction to update the accumulator. Other than that, at this point of period, we don't need to discuss much about implied addressing mode. The next thing is relative addressing mode. What is relative addressing mode? Why relative addressing mode is needed to be used? Let us understand this. This is very important. For this, I want some empty space. For that, let me go back and use one slide. Yeah. Let us talk about this program relocation. Yes. Very good. Yeah. Stay focused. You have written a program. The program is of 100 instructions. Okay. The program is of 100 instructions. Now the program is loaded in the main memory. Okay. The program is loaded from 150th location to 250th location, let us say. Okay. And now in the program, while you're writing the program, you're having a necessity of taking a branch instruction. Within your program, from the 4th instruction, you need to branch to 10th instruction. What you will generally write? You will implement a call instruction followed by the address to where you need to branch. So generally what you will say? Generally, you will write an address here to where you want to branch. But understand something. Stay focused. This is my program which has 100 instructions. My program is starting from the first instruction, is ending with the 100th instruction. This is my program. But within the 4th instruction, I made a call to which instruction? 10th instruction. Yeah, hold on. But of course, when I make a branch, I will go to the 10th instruction where the subroutine is originated. Generally calls are, triggers a subroutine in execution. There is a subroutine available right from the 10th instruction. After I call, the subroutine will start its execution. But the thing is, I can't implement the same thing in my, program, because if I do the same thing, what exactly is going to happen? The problem is, when I say call 10, this 10th instruction, I'm talking about my program. Within my program, I'm talking about the 10th instruction. But when it gets transferred to the main memory, I don't know exactly where my program is going to get loaded. If my program is exactly getting started from first instruction, I may say call 10, but I don't know from which location this program is going to get loaded. Let us say this program is getting loaded from 150. That means that your first instruction is loaded in 150. At that time, if I go ahead with this call 110, let us say in the 4th instruction, 150 at 153, if I say call 10, what exactly is going to happen? This 10 is a memory address which is not falling under your memory space, right? I hope you got my point. You cannot call 10 because this 10 will be falling under some other memory space. The moment you execute this, immediately the computer system will kick you out. The operating system will kick you out. So what we need to do is, we need to take a necessary care that the branches are appropriately taken. They appropriately will be branched to the respective location within the program. How that is going to happen? That is going to happen by using two addressing modes, because the program is getting relocated in the main memory when it is being executed. When the relocation is done, the program will be loaded from a specific location. We need to call from a specific location. So we need to call, make a call to a specific location. That is the 10th location of the program. The 10th location of the program will now become 159, right? So I need to make a call to 159. I hope you got my point. How exactly I can make a call? Of course, for this, I'm going to use two addressing mode. One is base register addressing mode and one more is relative addressing mode. Okay. The base register addressing mode is very simple. The thing is, every time when a program is loaded, the base register will be transferred to the base register. Whenever you perform this call instruction, what will happen is, this call instruction will use base register addressing mode. The address part of the instruction will be added to the contents of the base register. At that time, both will branch you to the appropriate location. I hope you got my point. That is, I want to branch to the 10th location. I want to branch to the 10th location within the program. Now when I add this 10 to 150, 150 plus 10 is equal to 160 is exactly the 10th location, not 159, sorry. 160 is exactly the 10th location where I need to branch within my program. Yes or no? But if I simply say 10, that will go to 10th location of the main memory, where main memory doesn't allow to execute at all. So this is one way. The second way is use program counter to go to the appropriate location. How you can use the program counter? I will tell you a way to use the program counter. Now let us say your instruction, the computer system loaded your program from 150 and to 250. Okay. Now in 154, you are having a call instruction. Now where you need to branch? You need to branch to the 10th location within the program. 10th location meaning from this instruction, if you go to 6 more instruction, it works for branching and looping in a program. Absolutely perfect. 159 was correct? 159 was correct? If that was correct, you put it that way. Okay. Now call 6. What is call 6 here? Here, from this position, if I skip 6 instruction, I will go to 160. Here what I'll do is, I will use the program counter, that is, excuse me, from here I just need to only go to 5 steps, right? Yes. I will put a value where if it gets added to the program counter, then the address will be reached. The corresponding address where we need to branch will get reached. So I will use the program counter when I add the value I add the value of the instruction that is specified. If it gets added to the program counter, we will be reaching to the specific address where we absolutely need to branch. I hope you got the point. Then, okay, then 10 minus 1, 9, then 159 minus 150 is equal to 9. Okay, then fine. I'm not recollecting, but fine. This is the thing. Did you understand relative addressing mode? Why relative addressing mode and base register addressing mode are the best addressing modes? Did I make it myself clear? Any doubts so far? You want me to explain any of these things? I will do it again. Is this clear? Vishal, Anu, Raj? Vishal? Anu? Yep. Once again, PC relative addressing mode works this way. We are going to use the program counter. The current instruction is, let us say, 154. 154 is a call instruction. It needs to call to a specific location, let us say 160. 160 is the target address. Now, call must be followed with a value where if it gets added to the program counter, we will be reaching to 160. So what must be the value? Here, if we say target address minus program counter value, then then that will be fine. That is, the value that must be present at this point is the target address 160 minus program counter value, that is 155. 160 minus 155 is equal to 5. So when 5 gets added to 155, we will be reaching to the target address, that is 160M. PGM relocation at runtime. Yes, of course, you're clear. Yes, you're correct. Okay. This is how the program relocation is going to happen within the computer system. And the next thing is base register addressing mode. Of course, I explained right now. One more thing is the index register addressing mode. Index register addressing mode is going to be useful for array declaration. Array declaration, how it is going to happen? Why we do require array declaration? Let us say you do have an array. You do have an array A of 100. That means that immediately a specific memory location will be allotted to this array. The array has been allotted from 100 to 200 location. After which I want to access the fifth element of the array. How do I do this? This will be transferred to the index register. The base address of the array, the starting address of the array will be loaded in a register called the index register. The index register is going to contain the starting address of the array, and every time when you want to access a specific location of an array, that location that is to be accessed, the address will be added to the index register value, after which when they get combined, you will arrive to the specific location where you want to access within the array. I hope you got my point. Okay, these are the addressing. Any addressing mode that I forget to? Yes, auto increment and auto decrement. Auto increment and auto decrement, if you don't have them, there are no loops at all. There is something called auto increment and auto decrement. Where are those? There is auto increment and auto decrement. Auto increment is going to implement post increment. You know what is post increment? I don't need to explain. You are the better and you are the best programmers in the world. What is post incrementing? Auto increment is exactly trigger one feature of the programming language, that is post increment. Auto decrement is exactly going to trigger one concept of the programming language, that is pre decrement. Okay, so without auto increment and without auto decrement, it doesn't work. The loops concepts will never work. So if you want to implement loops in your programming, first of all, you must be supported by the processor where it incorporated auto increment and auto decrement. This is the purpose of each and every addressing mode here. Of course, once again, direct addressing mode is for variables, immediate addressing mode is for, just a minute. Immediate addressing mode is for, what is immediate addressing mode? Cleared, we need different address. Yes. This, I know that by the end of, the session, you're going to have every doubt of you will get cleared. Okay, immediate addressing mode is for what? Constants. Indirect addressing mode is for pointers. Relative addressing mode, program relocation, and indexed addressing mode. What is indexed addressing mode? Tell me, what is indexed addressing mode? Let me put it this way. You answer. What is indexed addressing mode? Array, right? How much time you take? Indexed addressing mode is for array. Register addressing mode. Yes, I did not explain, I think. Hold on. Why we need to have register addressing mode? Anu, can I expect an answer from you? Why we need to have a register addressing mode? If you do not have a register addressing mode, let me tell you. We can't update a variable. Simple. Let us say there is a variable A. I want to update this variable. I want to perform A++. How do I perform? First of all, initially, if you want to perform any operation on any variable, reply takes time to go. Okay, fine. If you want to perform any operation on a variable, that operation can only happen within the processor. No operation can directly be performed on the memory location. The operations cannot be performed on the memory level. If you want to update a value, that value must be brought into the processor's register. If you cannot bring into a processor's register, there is no ever way for that value to be updated. If you want to update A++, you need to perform A++. What is the way that you perform that? A must be transferred to one processor's register R1, right after which all the updations must be performed on the R1, right after which the R1 value must be reflected back within the variable. This is how a variable is going to get updated. I hope you got the point. If you want to update a variable, you need to use which addressing mode? If you want to update a variable, register addressing mode. Once again, register indirect, there is no specific use. It will start auto increment and auto decrement. This will be act as a base to auto increment and auto decrement. With this, we have come to an end of this session. Of course, I explained you everything. Just a minute. Program relocation also explained. So that's it for the session. Thank you so much. That's it for the session. Thank you so much. Any doubts? If you do have any doubts, please ask me right now. Otherwise, we are done with the session. So that's it from the session. This is Anil Prasad Sorampudi signing off. Thank you so much.